I would like you to draw a triangle of angle 35 degrees, an adjacent side of 10 centimetres, so that's one that's next to it, and a non-adjacent side of 6 centimetres. Pause the video and give that a go. What you might find is that you could think of two different ways of drawing this, or indeed if you and a friend are watching this video, you might have drawn completely different shapes. The first shape you could have drawn would be your long 10 side there, an angle of 35 here, and a 6 centimetre line here. That's non-adjacent there. Your friend could have drawn your 10 centimetre side here, an angle of 35 here, but your 6 centimetre side looking a little bit more like this. Both of these fit the criteria that I've asked you for. And then if I said, well, find the angle opposite the 10 centimetre side, one of you would be finding this angle, which is acute, and the other of you would be finding this angle. In both cases, you should be using the sine rule for this. So we would be writing sine of 35 divided by 6, because here's my opposite pairing number 1, equals sine of my angle, green, let's call this one A, over 10. Gives sine A as being 0.95596 and so on and so forth, giving A as 72.9 degrees. Now, I also know that this other angle here must give me a solution, but I would go about solving the problem in exactly the same way, so I'm going to get exactly the same answer. To solve this problem, what we need to know is the relationship between the two angles we had before. To explore this, what I've done here is I've pulled together the two triangles into one single triangle. So we both know that they share the side 10 and the angle 35 in common. So I've placed these both, correct for each of my triangles. Now what I've been left with then is a sort of superimposed triangle on the end here with the two sides 6 in their respective orientations. Now I've also labelled those with the same length line marks because we know that they're both 6. Now what that does allow me to do is if I call the angle, the smaller one, B, the one we worked out to be 72.9, because this triangle is isosceles, I know also that the second angle in the base of that isosceles triangle is also B. But that helps me find out what this other angle will be, because both of these angles lie on a straight line. So the second angle to this problem must be 180 minus the first angle. This is called the ambiguous case of the sine rule. In the context we were given originally, we didn't know which one of the two values was going to be the correct one. So if we're faced with that in the exam, we need to find both of them. It is both the larger obtuse angle and also the smaller acute angle, and we know that the two angles are linked together by doing 180 minus one of them. So in the case we had before, which we rearranged to find out what the first angle was, we can now apply our rule for the ambiguous case of the sine rule and state what the other angle is, which is 180 minus my previous answer, which is an obtuse angle of 107.1 degrees. Key ways to spot this is to be aware every time you use the sine rule to make sure that you aren't being asked for multiple values. The other way of spotting it is for the word values. Find the values of the angle. That might be what the question does to indicate that you have to do more than just find one value. But basically, anytime you use the sine rule, you should just be aware that there has always got to be the possibility of another angle. Now, there are some things that constrain whether there is a need for a second angle, and I think you should have a think about those, and hopefully your teacher will go through them with you in class.